Hello and welcome to DLL Proxy Loading, the 25th video as part of our Red Team Fundamentals mini-series. In the previous video, we discussed the core fundamentals of persistence, including its concept as a whole, and some considerations when it comes to establishing it. We had a look at one of the most well-known persistence techniques via the registry run keys, which allowed us to regain access to the system upon every user login. This proved rather a methodical technique, given that users are likely to log in each day, which keeps our persistence execution sensible, yet frequent. However, although this method was indeed powerful, it is also one of the most widely recognized techniques for establishing persistence. Now, from an early age, the registry has been a highly sensitive area when performing red team assessments, given its capabilities, and is therefore likely to trigger numerous alerts for the blue team when tinkered with. Therefore, to mitigate this risk, in this video we will examine a far more stealthier and perhaps more flexible technique known as DLL proxy loading. As per usual, everything we teach in this video is purely for educational purposes. We accept no responsibility for your actions. Now, if you've never heard of what a dynamic link library, also known as a DLL or module, is, it is a type of file in Windows that contains program code and data which programs, including other modules, can load and use simultaneously. Essentially, it enables programs to dynamically perform specific tasks for which the module is designed. You can really just think of it as a shared repository of functionality that is made accessible to any program that requires it. Now, most of the module's functionality is provided through constructs called functions. If you've done some programming in the past, you will likely be familiar with the concept. They simply provide reusable blocks of code that perform their intended actions. Therefore, whenever an application requires specific functionality, it can reference a module's functions to perform that action rather than having to repeatedly duplicate the same block of code. Now, to kind of better illustrate this, I've built a very small program that leverages the message box function. And as you'll see here, there's no definition for the function anywhere in the program, but rather the program invokes the function from a specific module. So let me actually illustrate this. Use Control F5 to run the program, and you'll see here we get a message box from our program that prints hello from message box. Now, if we take a look at Process Explorer and the modules that our program loads, upon selecting our program, you'll see that there are numerous of them. And you can view all of these modules via the DLLs column by selecting View, Lower Pane View, and DLLs. Now, as part of these modules, there is the User32 module where the message box function resides. And if we actually take a look at the function's documentation here, scroll down a little, until we come to the requirements table, you'll see that the module that implements it is indeed User32. So our program runs, loads the module, and then references that function as part of that module. We can actually confirm this ourselves if we examine the export table of this specific module, which can be found within the C drive Windows System32 folder. Open it up with CFF Explorer, go into the export directory, and then as part of this table, you'll notice here that we have numerous different function exports. And we'll get into function exports shortly. However, if we scroll down enough here, we'll come across an export that is named message box W. And this is precisely what our program references. Now, modules provide several key advantages. Because the module can be modified independently and then loaded as part of the program, this reduces the program size and improves modularity and ease of updating. Ultimately, however, modules are designed based on the principle of not reinventing the wheel. Why need to constantly create custom functionality to achieve what may already be provided by standard functions? Now, a module contains two primary types of functions, internal and exported, and each will behave differently when used. Internal functions are often designed to be called exclusively from within the module in which they are defined. And these types of functions will often form components of a larger function. Exported functions, on the other hand, as we saw with our user32 module, can be called externally by any program or module, assuming that it has a valid reference to it. These are the functions that programs will reference in order to achieve their certain objectives. Now, from a red team perspective, an exported function enables what is known as redirection, whereby the function definition resides elsewhere and the reference module proxies calls to that function. And this is accomplished through the use of a forwarder. And although a forwarder appears identical to a regular exported function, it does not contain the function itself. Instead, it contains an entry, or more precisely a pointer, that specifies where the function call should be forwarded. So as you can see there in the image provided, when the program attempts to call function B, that call goes through our proxied module, which sits in place of the original. This module then takes the call and forwards it to the original module where its intended functionality resides. So the program still receives its desired functionality, however, we are acting as the intermediary in this process. Meanwhile, in the background, the module performing the forwarding is also executing whatever functionality it requires through the context of the calling program, which in our case, this would be executing arbitrary code, or more specifically, establishing persistence. And really, this is the fundamental anatomy of DLL proxy loading. By replacing a program's original module with our own and forwarding its function calls to the intended module, we can execute whatever we desire while still ensuring the program runs correctly. So let's put this into practice and see how we could utilize it during our assessments. Now, before we begin, there are several requirements that we need to meet in order to leverage DLL proxy loading. One of the main requirements is that we have write and modify access over the target programs folder. This will allow us to modify the program's contents and thus replace original modules with those being proxied. And then we'll need to select the appropriate module we are intercepting, obtain a list of that module's exported functions, and then develop a replacement module that redirects all of the exported functions from the hijack module whilst incorporating our payload. And then lastly, we will need to replace the original module with our proxied one. And so by following these steps, we will not only be able to establish persistence, but also ensure that the application's functionality remains intact. Now, there are several different ways in which we can locate program folders with weak permissions, but one of those ways in which we can do so is by using an automated tool like winPEAS. And what winPEAS will do is it will enumerate program folders that have modification rights over them and thus report them back to us. All right, so let's execute this tool. And once the tool has finished executing, you'll see here that as part of its installed applications check, it managed to find a folder within the program files named Notepad++ that our vvolkov user has all access rights over it. And we can actually confirm this by using the CACLS tool, which displays access control entries for files and folders. And all that it requires is the path to the file or folder we are listing the entries of. So in our case, that will be C program files, Notepad++. So if we execute this, and what you'll see here is a listing of all of the ACLs applied to that folder. And one of the first entries here is for our user, vvolkov. Now, reading ACLs is a beast of its own. However, we can assume that we have full access rights based on the F value. And I will leave a link to the documentation where you can find the description of all of the ACL rights and what their identifiers mean. So you can see here, F is for full access. Now, once we've identified our access rights, we are going to want to select a module we will be hijacking. Now you can choose pretty much anything, but in our case, we will be using the MPP export plugin. And I like to choose the modules with the least amount of size because it just leaves less room for error in the case that there are thousands and thousands of functions that we need to redirect. And once we've chosen our target module, we can use the download command to download it. And then to list the export table of our target module, we can use the rabin2 command. And this tool is part of the radar reverse engineering toolkit. And as you'll see here, by using the e-switch, we can list all of its exported functions. So if we execute this, you'll see that we have 6 functions in total, and all of these functions we need to redirect. And to do so, you can use a template we have already built, where you can find it in our GitHub repository, and I'll leave a link to it in the description below. Now we'll get into the program code shortly. However, one of the first things that I want you to focus on is the pragma directives. And in layman's terms, a pragma directive is primarily used to specify special instructions for the compiler. Now in this case, we are specifying a special instruction for the linker. And as part of these instructions, we are instructing the linker to perform an export. Now for this to make more sense, I have defined the syntax of what is expected. And one of the first functions that it requires is the name of the function being exported. The second value is the name of the target module to which the function is forwarded. And keep in mind, we do not need to specify the .dll extension here. And then lastly, we specify the receiving function of the target module that will receive and process the forwarded call. So as you'll see here, the exported name will often just be the value of the function that is exported from the legitimate module. And the module to which the function is being forwarded to will be the original module. And then lastly, the receiving function will typically be the function that is forwarded. Now I know all of this can be a little bit confusing, but just bear with me as it will make sense shortly. Now then, to redirect to the exported functions, I've already written a Python script that will automatically build us an export entry list. And all that this script does is use the PE file library to access the module with its export table, and then using that export table, it will build us the pragma directives automatically. So if we specify our target module, you'll see here that we get a listing of all of the pragma directives of the functions being forwarded. Okay, so we're going to need to copy all of this. So I'm going to use the Excel command, and then I am going to update our proxy module with the pragma directives that will forward the functions being redirected. Now, as for the program code itself, I won't go into detail. We do go into detail about this in our actual course, which will be released shortly. But in summary, what we are doing is performing process injection. So we take a snapshot of all processes on the local system to obtain the PID of explorer.exe, and then we take that process and inject shellcode into it. So as you'll see here, we use functions like virtual alloc to allocate memory within the target process, and then we use write process memory to write our shellcode into that process. And then lastly, we create a remote thread which starts at the injected shellcode, which just fetches the stage 2 payload, which is then injected into memory, and we establish a Sliver implant session. And again, I won't go much into detail, but you can find this template in our GitHub repository. And should you want to learn more, you can take our full course. A little bit of self-promotion there. Anyway, now that we have the listing of our pragma directives, we can compile the source code, and we are going to compile this as a shared library. Save this as mpp export.dll, and then specify the source code that we are compiling. And should everything work as expected, we should have our replacement module. Now, one of the things I want you to focus here is the module we are forwarding to. And more specifically, you'll see that the module we are forwarding to has the number 2 appended to the name of the original module. And this is because we are going to keep the original module within the same directory and then upload our custom one as its replacement. So now, as part of the MPP export folder, we have 2 modules. The module named MPP export is the module that will perform all of the forwarding, and the module named MPP export 2 will be the module that accepts all of the forwarding and thus its intended functionality. Now, I have already generated and placed the stager that we are going to be executing. And before you do execute the stager, just make sure you have the stage listener running. That is, if you are following our example of using stagers as a means of persistence execution. You can pretty much use anything, just ensure that whenever you are executing something of your own functionality, you execute it within the case block of DLL process attach, as this will ensure that your code executes whenever the proxied module is loaded. Okay, so now back as the victim, whenever the victim opens up Notepad++, you'll see here that Notepad++ opens successfully, and then within our Sliver interface, you'll see that a new session is established. However, the main principle here is that whenever the user executes Notepad++, we will establish persistence through it. So it still remains a rather sensible technique because it is unlikely that the user is going to execute Notepad++, say 20 times in a row, but something like maybe once or twice every single day. So we still have a relatively frequent means of persistent access. And that concludes our exploration of DLL proxy loading. I hope you found this video informative. In the next video, we will take a look at one of the last persistence techniques that leverages AnyDesk and its capabilities for graphical persistence whenever we require an interactive means of accessing the system. Following that, we will delve into privilege escalation, and then tackle the beast that is Active Directory. In the meantime, feel free to join our Discord server to stay up to date with us, explore our courses, soon to be released labs, and one of the finest red teaming courses available. I've left a link to our group in the description below. Until then, stay safe, and I will see you in the next one.